Okay, good afternoon for people who are joining us pretty much everywhere except for BC and the West Coast, and good morning to those of you on the West Coast. My name is Erin, and I have the pleasure of introducing today's webinar on easy road design using Lidar data. With me is Craig Spears, one of our software engineers, and he's going to be handling the technical aspects of today's presentation. A bit of a public service announcement for some upcoming webinars that we have. We've got culverts and fish passages coming up on January the 10th. On January the 31st, we're going to be taking a rather in-depth look at cross-section template components. This is adding, modifying, and using our e-library to work with cross-section components. And for those of you not as familiar with RoadEng, this would be equivalent to something like an assembly in Civil 3D. Finally, on February the 21st, we are taking a look at our terrain module in Terrain Tools 101, looking at site design, terrain modeling, and all different types of features and functions available for drafting that we've got within that module. Now, for what we're covering today, today's webinar will be done in our RoadEng program. It is either a 2 or 3 module program. The first module is a field note entry module called Survey Map, and we will not be using that one today. However, we will be starting in our terrain module for the import of our LiDAR as well as selective thinning around our area of interest. From there, we're going to be incorporating a field traversed GPS track into our data set, moving all of that data as our original ground over into our location module for the creation of a road design, including the development of our vertical and horizontal alignments, a comparison of costs if we were to update or change these alignments, our selection of our cross-section template, and depending on how much time Craig has, we're going to be doing our earthwork balancing, and this may be using our add-on to RoadEng called Softree Optimal. Finally, I will be taking it back into the terrain module and updating our LiDAR surface with a designed road. That's a brief look at what we're going to be covering today, and with that, I'm just going to pass the presentation here over to Craig, and he's going to take us into the technical.
Thanks, Erin. Good morning, good afternoon, everyone. I'm just going to make a quick switch here, so hopefully you can see my screen now. So one thing, just to be clear from the beginning here, is that this demo is going to be oriented towards low-volume roads, forestry roads, mining roads, that sort of thing. This is not the typical project that you'd be doing for like a county road project. So definitely oriented towards low-volume roads. And the focus of the seminar, I think I'll probably spend most of my time talking about actually handling of LiDAR data, and that'll be done in the terrain program. And yeah, there's a few tricks so that if you're a more experienced user, I think you'll gain some knowledge here when I show you a few tricks. And if you're a novice user, I think you'll get a good understanding of how to begin working with LiDAR. So LiDAR has, in the last 5 years, become very popular for resource road design. It's hard to find companies now that aren't using it. And yeah, I think the results are very positive. LiDAR coming from either aerial surveys or more and more drone type surveys. So they're all equivalent. The key feature of LiDAR data is that there's a lot of it, and so you have to deal with it carefully, otherwise you just get completely inundated with a ton of data. So let's just jump right in here. I'm going to, first of all, bring in some LiDAR data into the terrain program, and to show you what I've got here, I've actually taken a subset of LiDAR files and reduced it to 4 tiles. As far as formats for LiDAR, we recommend LAS format. I know that there's some advantages to grid formats and DEM formats because they save on disk smaller, but in terms of using them in RoadEng, we have to expand them into a 3-dimensional file, and the advantage of using the grid format quickly disappears and you get a ton of points. In fact, it oversamples the data, and it's not the best way to go. So if you have a choice, if your provider gives you some options, ask for LAS format. It's quite convenient. So let's just go ahead and take these LAS files, drag them into Train, and you can see here that the LAS file actually can have layers, and you want to be sure that you get a layer that has been filtered, so the canopy has been taken out of it and you're getting the ground layer. There is no functionality in RoadEng to do that filtering, so it needs to be done in other software or by your LiDAR provider. So generally with LiDAR, you never really want to see all the points. It's just too much. So you always turn off the display of points. I'm going to keep this extents border just so you can see the area. I'm just going to go ahead and do this. It tells me that coordinate system's undefined. And now it's importing the data. It takes a second. And when you insert a file, the data comes in selected. And the first thing I want to do is to unselect it. And there's a little bit of a trick to that. First of all, if I have my mouse in the plan window and I hit escape, it'll stop drawing. If you ever get into a long, slow, painful draw, just move your cursor in the plan window, hit escape. And now that it's stopped drawing, I just simply select something in the white area of the screen, and now I have disabled the drawing of all those points. So I can move around, and there really is no reason to display all those points. So I've brought in 6 million points. We'll have a look at them in a little bit more detail. With version 8, we've increased the number of points that we can handle. It's virtually unlimited. It's bound only by how much memory you have. But realistically, I'd say try to keep the number of points in your surface under 10 million. I mean, it's really about speed, computational speed, and things like that. 10 million points, you're probably going to be working quite quickly. So that's just a rule of thumb. Some projects you might want to go up higher. Some you'll make them less. Now, there, we've got the LiDAR data. We easily could work with this number of points, but to illustrate how I would thin them, I'm going to bring in a shapefile that's got some field work in it, and I'm going to just bring that in. And of course, if you're working with other data like shapefiles or GPX files, you want to be sure that it's in the same coordinate system as the LiDAR, whatever that might be. So yeah, they need to be in the same coordinate system, or this is just not going to work. So there, I've brought in two road sections into my file, and they sit. One of them straddles a couple of the panels. So the first thing I want to do, because I'm working on these roads, I've gone out and I field located these, and I want to use them as P-lines for my design. So when I do the design, I can reference those features, offsets to the field run traverses. So what I'm going to do is to filter the LiDAR data in these areas of interest. And to do that, I go in, there's a couple of ways to do it. The one way I'm using is to do it after the data's come in. It is also possible to do it when you bring the data in. But let's just go with this one. It's a newer method. So I use the Simplify Surface Data dialog, and I'm going to change the grid spacing. So what's going on here is I'm going to exclude these areas, and outside those areas I'm going to sample the points at about a 5-meter spacing. So it's pretty coarse. The LiDAR is obviously much more accurate than that, but I don't need it really, because because all I need is detail inside these corridors. So I'm going to add corridor feature, select that, and here's my first GPS feature. I'll add that with a corridor width of 100 meters, and then I'll add the other GPS feature. Again, as a corridor, select that, GPS 1. Okay, so we've got 2 corridor regions, and those regions will not be filtered, excluded regions. So when the filtering happens, it'll be outside those areas, and it will do it on a 5-meter basis. You could go higher. It's really up to you. I should just point out also there's other techniques for simplifying the surface, and the closest point removal, that's a slower technique, but it produces a better filtered set. Again, I don't really care about anything outside the corridor, so I'll use a very simple, fast technique. I'm just going to go ahead and do this. Not enough room to undo. It's going to do its thing. And it's going to reduce the number of points from 6 million to something. I'll know in a minute. And when it does that, everything's going to be a little bit faster. So we've gone, now we're under 1 million points for these 2 sections of road. Each of them, I think, is about 1 kilometer long. And that's all I care about. You can see the density of the points in there. Very dense in the corridor area. Outside it, very sparse. Good enough. So again, I just click in white space, and I'm no longer displaying those points. And now I can actually create a terrain model. So let's just go ahead and do this. Generate terrain model, maximum side length. This is to do with the boundary of the area where you're tinning. You don't want to go too far outside the limit. So I'll say the longest triangle I can have is 50 meters. And contours. Strictly speaking, I get this question quite a bit, and people think that the finer you contour things, the more accurate your model will be. That's actually not the case. The contours are just a visualization. You don't even need any contours, and you're still getting the accuracy of your model. So don't go necessarily to 1 meter contours because you think you're getting more accuracy. You're not. You may actually be slowing down all your drawing and working with the data. So I'm just going to create the tin model. Just under 1 million points, goes very quickly. Now it's creating the contours. And there it is. I usually like to have a quick look in 3D just to get a visual. So I'll create a 3D window. There we are. There's our tin model. And if you look in on those road areas, you'll notice that the detail is quite a bit higher in the road areas where we selected. So I've got a terrain model. Now I want to go back and I want to create the P line. So when I do the design, I will have a P line. I can use that P line to reference offsets in my road design. So I'll zoom in here, find those GPS features. There's one, and there's another one down here. Scroll down, hold the shift key down. Got them both selected. I just might make their line a little thicker so I can find them next time. There they are. So first of all, notice that usually GPS elevations are pretty suspect. So in this case, it doesn't have any elevations. There was no elevation in the shapefile. And I want to get elevations. I want to actually drape these P-line features over the tin model to pick up elevations. And that's easy to do. You just turn on modeled and leave elevations off, and you can see there's a picture there of what's going to happen with those features. They're going to get draped on the model. So let's just go ahead and do that. And now they appear in the 3D window. They're sitting, they picked up their elevations, and they have elevations here. So yeah, we've taken a field run GPS, very inaccurate elevations, and we've dropped it onto this LiDAR model. We can also, of course, get a profile for this. So there's a quick profile. And yeah, it's got elevations, and not only does it have elevations at the points, the turning points in the traverse, but it's got elevations at intermediate points. So let me just put a symbol on these points, apply that. So those are the original points that were picked up in the GPS. And if you look, just zooming in a bit here, if you go in between the 2 points, you'll notice that there is actually changes in elevation between the known points. So every triangular facet that it crosses, it picks up the variation along the traverse. So that's good if you're wanting to see that. But if you save this file the way it is, if you save this traverse the way it is, you will get a lot of very short legs in the traverse, and you won't be able to recognize the actual points, which might be stations marked in the field. So I'm going to do a little trick to keep the elevations and get rid of those intermediate points. So I only have elevations at the turning points. So what I do is I go back to, first of all, let me select this feature. There we go. So it's a draped feature. I'm going to make it unconnected. You can see that what it's doing there. Apply that. So I got a bunch of points. Each of those points is dropped on the model, but there's nothing in between them. And now I'm going to turn off the draped property. I'm going to put elevations on and then reconnect them. Apply that. So now I have a feature that only has elevations at the turning points, which is a bit more manageable. Okay, so oh, and by the way, well, I'll come back to it in a second. Let's finish this thought. So here's my traverse feature, and I want to reference it in location. So I'm going to do a file save as, and I'm going to choose survey file format, and I'll call it P-line 1. Oops. There it is. And I'm not going to calculate side shots. When we do the road design, the side shot information will all come from the LiDAR model. All we want here is the P-line itself, so we can get offsets from our design line to that preliminary line. So I'll just go ahead and do this. And I'll look over here in the folder, and there is a TR1, and I'm sure many of you know what a TR1 file is. I'll just quickly have a look at this. Open. And there it is. It looks just like a survey file that's been hand entered, and we can reference this in our location. But again, we only want to use the P-line for the offsets. We want to get the ground slope from the LiDAR data, which is really accurate. The other thing I forgot to mention when I started was that I'm using version 9. A couple of reasons for that. We get some extra testing with it, and the other, maybe more important reason is I can kind of tease you a little bit about some of the features that are coming, and possibly get some people out there who'd like to beta test. So one of the features in version 9 that I can do with this LiDAR model is if I was doing some yarding analysis, cable logging analysis. I can do something called a D-line explore option. And I'll just change the calculation here, simple third point deflection. And I'll come in here on this model. I've got to be in the plan view. I can pop, extends outside the model. You can see there I'm getting a graphic showing me what my deflection is like. The red is not, has no deflection. Those are places where the clearance is below ground. So you can do things. You can do a study of cable areas. If you like those, if you like that setup, you can just accept it, and you will get those profiles all set up with your cable logging. So there's a little teaser on version 9. Okay, back to my main track here. So I saved the traverse, and I want to save this terrain file. So I'll save it. What am I doing for time? Oh, I'm going to be probably going overtime a bit. So I'm going to call this topo. And it takes a second to save that. And there's my file. And I've got my traverse file. And another thing that I think is an important concept is to separate your files. So I would actually take these features out of this file and put them in their own terrain file. Right-click, copy. Maybe make another terrain file just to put them in. And the reason for doing that is that you can turn them on and off as you need. Copy, paste. So there they are. I would call these whatever and take them out of this file. Similarly, I had some image files that came along with the LiDAR. I put them in another file. I had some ECW files. I put them in another terrain file that has images. So I can come in the background here and turn them on and off easily and independently instead of stuffing everything in the same file. So you just add this images in here. Takes a second, loads up the images. So I think file organization will help you quite a bit if you keep the line work separate and images separate. Don't put them all in the same file. You'll find it much more useful. So there's some imagery that came with the LiDAR. Okay, so got to pick up the pace a bit here. I'm going to switch over to the location design and do a very quick location design. Fire this up and create a new design. Now, I'm going to use terrain surface. That's going to be my original ground surface. Oops, want to be in the right folder. There we go. And the P-line traverse now that we're going to reference offsets to, that's in my PR1 file. So there you have it. You don't need to have a P-line traverse. If you were just pegging a road in, you just start up with a surface. But in this case, I've actually located the road beforehand. I've gone out, done a recce on the route, set up a P-line, a GPS to P-line. So I want to reference that in my final design. Just fire this up. And there you go. We've got the usual road scenario plan profile cross section. So we've got a typical low volume road template set as the default, and I've got, because I put in a P-line, I've actually got a starting alignment that runs along the P-line, and there's my profile, which is following basically just the ground. That's the default. I haven't got a profile. So let's fix that. I'm going to first of all call this. I'm going to create a profile by using our optimization tool very quickly. Yeah, so that's going to be original ground, and then I'm going to add a new profile. Call this opt. This is covered in other webinars too, so don't sweat it if some of this goes by the board. I'm going to create curves on this, vertical curves on this, minimum curve length and tangent length there. It's a steep section of road, so I'm going to increase this to 17. Sag and crest for a low volume road, 1010. Just go ahead and add that. And then I'm going to put a control point because we started on an existing road. So I'm going to add a control point at the start of the alignment. There it is, station 0. That's the elevation that's found. What else do I have to do? I think that's a bit it. Let's just go ahead and create a profile. I'll run the optimizer process. This road looks to be just over a kilometer long, I believe. It's a spur road. When it's got a profile, we'll have a look at what the cost, what cost we would expect as a ballpark cost for the road. Of course, I have done I'm using this tool. You could have simply gone in and created the profile by manual procedures, the same as you do for a P-line or any kind of conventional survey. Okay, so we've got a profile, and there it is. Let's come over here. We'll set this current, have a look at the cost. Just anchor that down. So we've got a cost of about $200,000 for a section of road. That's about 1,200 meters long. And some fairly steep grades in it, but there it is, and you can see that it has balanced it. And I'm at a position here where I have something to start really, if I want to dig in and start designing this in greater detail, I'm in a good spot right now to do that. Okay, so that's really what I want to show you. The next thing I want to show you quickly is how to export this road surface out and incorporate it back into the terrain model, the original terrain model. So just minimize this for a second. And I've got over here a design that I did this morning. It's not a great design, but I did put some horizontal curves in it. And there's my black P-line. I put some curves coming around the switchback and tidied it up a little bit, not much, and then I re-optimized it, and that's what I've got. So now I want to put it back into the original surface. So I go up here and I save this file and I choose a terrain format, TerX format, version 8 terrain format. I'm going to call it, I did this already, I'm going to call this subgrade 1. And many of these options I don't require. Really all I want is the cross sections when I do this. Center line, I could include that. I definitely want to have a boundary on the surface. I want to edit it in terrain after I've done the export. And that's it. Let's just go ahead with this, see what we get. So I've saved my design file as a terrain file, and the surface that I exported was the subgrade surface. And we'll just have a quick look at that. You'll see what's going on. So there is the road surface from the limits of excavation to the limits, from the limits of excavation. And this surface I've got saved as subgrade 1. And there's lots of things you can do with this surface. Machine control. You can actually do another volume, surface-to-surface volume calculation with this. You can contour it. You can do all kinds of things. It's a surface. But now I want to go back and merge that surface into the original surface. So I'll go back to yet another terrain file, and I'll open up my original surface. Luminar. So there's my original surface. Actually, I'm in this folder now. Sorry. There's my original surface. It's taking a second. Okay, now I'm going to, I have a couple of options. I'm going to merge that surface that I just created back into this surface. So I can do that through terrain modeling, merge terrain. And instead of doing what is often done, which is just bring the subgrade surface in and merge it all together and to create a new surface, I'm actually going to do something slightly different that some people may not know about, is to actually cut a hole in the original surface so I can see the disturbed area. It'll be a little more visually. So I'm just going to create the hole instead of actually merging it. Press OK. I need to get my subgrade 1 surface that I just exported. And this takes a second. It's got to do a bit of work here. So somewhere here, I know what I have to do. I have to regenerate the 10. Cut a hole in it. I won't bother contouring it to illustrate what's going on here. There. So you can see what I've done is that in the original ground, I've cut a hole. So there's a hole where the new grade is been placed. And now I can do a trick here, which is to render the background, the actual subgrade surface in that hole to get a visual on it. There it is. There it is. I'll display the triangles. I'll give it a funky color. Shade the triangles. So there. And of course, it's just a way to visualize it. And of course, I could have put it back into the original surface, merged them together, recontoured it, and possibly used that surface to design something else. It could be, a parking lot or a pad or something off of that surface, so you can actually chain these things together and create more than one design on that surface. So yeah. Anyway, that's the that's what I wanted to show you. Is there any questions? Be happy to answer them. Well, I will take it that either everyone fell asleep during my presentation or I was so good at explaining things that there's no questions. So anyway, I'll pass over to you, Erin, if you want to close off.
Yeah, I just wanted to thank everyone for joining us for our last webinar of 2018. And we look forward to seeing you all back with our webinar series in 2019.